Welcome to Daily Papers, the podcast where we break down fascinating new research into bite-sized conversations.
Today, we're diving into a question that sounds like it's straight out of a sci-fi movie. When an AI plays a game like chess, does it actually understand the game like a person does? Or is it just a super-powered mimic?
It's a huge question. We see AI systems doing incredible things, but we don't always know how they're thinking. This paper uses the classic game of chess to peek inside the mind of an AI and see if it's on the same wavelength as us.
The researchers studied a powerful chess AI. This isn't like the old chess computers like Deep Blue that beat Garry Kasparov, which worked by calculating millions of moves per second. This is a modern AI, a transformer model, which is the same kind of technology that powers systems like ChatGPT.
Exactly. Instead of brute force calculation, it learns by analyzing millions of games. It develops something that looks a lot like human intuition. It can just look at a board and say, that's the best move. And it's usually right at a grandmaster level. The question is its intuition based on the same ideas a human grandmaster would use?
Right. Human chess players think in terms of concepts. Things like center control, the idea that controlling the four central squares gives you a strategic advantage, or creating a knight outpost, placing your knight on a strong square where it's protected and can't be easily chased away. These are abstract strategies.
So the researchers set out to test if the AI understood 6 of these core human concepts. They did this by looking at the AI's brain, so to speak. An AI like this is made of layers of artificial neurons. The first layers see the raw data, the position of the pieces on the board. And with each subsequent layer, the thinking gets more and more complex, until it spits out a final move.
And what they found is kind of mind-bending. In the early layers of the AI's network, it seemed to think just like a human. When the researchers tested these layers, they could identify concepts like center control with up to 85% accuracy. It was as if the AI was starting its thought process by saying, okay, who has control of the center? Are there any good outposts for my knights?
It seems like we're perfectly aligned. The AI is learning chess the right way, the human way. But this is where the twist comes in. As the researchers probed deeper into the AI's network, into the layers that are most responsible for its incredible skill, that human alignment just faded away.
It completely deteriorated. By the final layers, the AI's ability to recognize these same human concepts dropped down to around 50 or 60%. It was basically guessing. This reveals a fundamental tension. The part of the AI that makes it so good at winning is the part that thinks the least like a human.
It's like the AI starts with a human playbook, but then scribbles all over it with its own strange, alien logic to get that extra edge in performance. It suggests that as we optimize these systems to be the best they can be, they don't become more human-like, they become more alien.
But the researchers had another, even more clever way to test this. They thought, maybe the AI hasn't really learned the concept of center control. Maybe it has just memorized thousands of opening positions from standard chess games, where controlling the center leads to a win. How can we test for true understanding versus just memorization?
And the answer is a wonderfully chaotic version of chess called Chess 960, or Fisher random chess. The rules are identical, but the starting position of the pieces on the back row is completely randomized. There are 960 possible starting positions.
This is a brilliant test because it makes memorizing opening moves totally useless. You can't rely on patterns you've seen before. You are forced to rely on a pure, abstract understanding of chess strategy from the very first move. The concept of center control is still just as important, but you have to figure it out from a position no one has ever seen before.
So they put the AI to the test. They took the model that was trained on standard chess and had it play Chess 960, and its understanding just fell off a cliff. Its accuracy at spotting those core human concepts dropped by another 10 to 20% across the board.
It's the smoking gun. It shows that the AI's apparent understanding was fragile. It was relying heavily on familiar patterns from standard games. When those patterns were gone, its conceptual grasp weakened significantly. It hadn't really learned the why behind the strategies, just the what that works in common situations.
And this is so much bigger than just a game. It gets to the heart of what we call the AI alignment problem. If we want to build AI to be our creative partners, to help us with things like scientific discovery or composing music or medical diagnoses, we need to know that we share a common conceptual ground.
Exactly. If an AI doctor proposes a treatment, we want to be able to understand its reasoning. But this paper suggests that the very process of making an AI better and better might cause its reasoning to become more and more inscrutable, more alien to us. It could be giving us the right answers, but for reasons we can't comprehend.
The paper calls this both a warning and an opportunity. The warning is that an AI that seems to understand us might be operating on completely different principles.
And the opportunity is that by identifying where this break happens, seeing that the human-like thinking disappears in the deeper layers, we might be able to design future AI systems that can maintain that alignment. We could build AIs that are not just powerful, but are also genuine creative partners.
It's a fascinating look into the emerging minds of our own creations, using a 1,500-year-old board game to probe the alien intelligence of the 21st century.
A perfect example of how sometimes the oldest questions give us the best tools to understand the future. That's all for this episode of Daily Papers.